This lecture is about landfills, and it's based on Module 53 from Environmental Science for AP by Friedland and Relyea. So here we go. So sanitary landfills are what we typically think of as a landfill, one of the ones that's built here in the United States. And they have several characteristics. So the purpose of a sanitary landfill is to concentrate and contain our garbage without creating any hazards to public health or safety. So the way that they do this, some of the things they need to take into consideration. So first of all, leachate is produced in landfills. This happens when rainwater lands on the surface of the landfill and filters down through the trash or the garbage and collects or dissolves chemicals and possibly like fecal matter, dirt, anything that's in the trash. It collects it along the way, and then at the bottom of the landfill you'll get that sort of leachate, that super polluted water. We also need to think about site selection. So this becomes an environmental justice issue. Where is the landfill going to be located? What impacts is it going to have on the local community? Is it going to affect property values? Is it going to affect human health with all the garbage trucks that are coming to and from the landfill? So choosing where to put the landfill is a big decision. And the environmental justice part comes in because a lot of times the site location is not exactly just. Landfills typically tend to be located near poorer communities or communities that have less political power. Also, you need to make sure that you monitor the pollution that might be associated with that landfill. And then there's federal legislation that oversees the construction and maintenance of landfills to make sure, again, that they aren't producing any kinds of hazards to public health or safety. So here's an example of a poorly designed landfill. This is what you don't want to do. So you can see down below is the water table, and that's in a type of rock called limestone. And basically what they did is they just dug a big pit in the ground in their clay and silt up there. And then they dumped all the solid waste in it. So whenever it rains, that waste, the water is going to filter down through the waste. It's going to soak down through the ground. It's going to end up in our groundwater. Also, there's nothing containing that waste. There's no cap on it, so you're going to have smells. You might have animals or people digging through the dump, so lots of issues. This is a bad landfill. This is not what it's supposed to look like. This, on the other hand, is an example of a good landfill. So if you notice there with number 1, we've got the garbage trucks coming in and out and dumping the garbage into the landfill. The number 2 there shows a compactor that's helping to compress all of that waste. If you recall from the lecture from modules 51 and 52, we talked about how all the garbage is compressed in the landfill, and that creates an anaerobic environment so that methane is produced. So we'll get to that on numbers 4 and 5. You can see down below number 3 as showing you the leachate collection system. So the walls of the landfill are a layer of clay on the outside and then a layer of sand next to that. And that sand actually contains the trash but allows the water to filter through. So in this case, we actually want the water to move through the landfill down into that gravel down below. That gravel is your leachate collection system, or it houses the leachate collection system. Notice below the gravel is the continuation of that clay liner. Clay, as you know from the soil lab, water does not percolate through clay very quickly. So when you put water on clay, the water just sits there. So that clay liner is supposed to help prevent the leachate from moving out of the landfill and into the groundwater down below. You can see the groundwater. And that white represents the leachate collection system. If you move over to number 4, that's the side of the landfill that has already been filled. So they've covered it with a layer of dirt and then some grass over the top. And that's to help prevent any gases or smells from the landfill escaping and polluting the nearby community. And then number 5 represents the methane extraction system. So again, we know that methane is going to be produced from landfills. We want to make sure that we extract the methane, because then you can compress it. It becomes compressed natural gas and it can be burned or used as a fuel. And also then it's not going to cause your landfill to explode or catch on fire. So benefits there. And then notice on the far right of the picture, we've got the groundwater monitoring well. That's to make sure that we don't have leachate getting into our groundwater. If that monitoring well ever detects signs of leachate, they would know that they need to immediately stop pumping groundwater out of that source, and they need to address some issues there with the sanitary landfill. So you can see there's all kinds of safety precautions that are put in place in a correctly designed landfill. Now, part of the problem is with landfills is they still do take up quite a lot of space, so we'll have to figure out how to address those issues. So just to check your knowledge, key components of a sanitary landfill include all of the following except A, a leachate collection system, B, a permeable liner to allow drainage, C, a groundwater monitoring system, or D, a methane collection system. So go ahead and pause if you need to. And the correct answer is B. All of those things are part of a sanitary landfill except a permeable liner to allow drainage. We actually do not want to allow drainage. We want to make sure that all of the leachate stays within the landfill and is collected by the leachate collection system in Part A. All right, so if we are not going to put our trash in a landfill, or we want to do something to reduce the volume, we might want to consider incineration. And there are some places that do incineration. So basically, they take their solid waste before they dump it in a landfill, they burn it, and that's to reduce the volume. So the trade-off here is like either you keep the waste intact and put it in the landfill, and you don't produce air pollution, or you burn the waste and then dump it in a landfill and you do produce some air pollution. So problems can go along with this. On the plus side, with incineration, you can produce some energy. So some communities will see that as a benefit. Now, the ash that's produced through the process of incineration is tested for its level of toxicity. If it's too toxic, it has to be disposed as a toxic substance in a special landfill, a hazardous waste landfill that has even more security precautions. And so that does cause a drawback because if you're producing toxic ash, it's much more expensive to dispose of it in a sanitary or a secure landfill, one of those hazardous waste landfills. If the ash is non-toxic, it can be used as cement, or it can be placed in a sanitary landfill with ordinary garbage. Now, some of the problems with incineration, some of the reasons why we don't do it more often, is that it's a high cost to build and maintain incinerators. It does actually concentrate toxins, so it brings together all the worst chemicals that are in our manufactured goods. So all of those chemicals found in plastics and any residue or that's found on any of the wood products or laminate or anything like that. And then it also does release air pollutants. And we just spent a whole unit learning about how bad air pollution can be for our health. So here's a picture showing how an incinerator works. You've got your garbage trucks at number 1 that are dumping all of the trash into this bunker. And then at number 2, they've got a crane that picks up the stuff from the bunker, drops it into the hopper there on top. And it allows all of the stuff to fall down into number 3, which is the incineration chamber. That's where the stuff is actually burned. And then as the ash is produced, it's kind of like a big barbecue, like a charcoal barbecue. So as the ash is produced, it falls down through the bottom of the incineration chamber and into the ash bunker, where it's then tested, or it would need to be tested for toxicity, and then hauled away on garbage trucks. Now, the air that's produced as a result of that, all of that incineration is passed through the baghouse filter, and that's to help filter out some of the pollutants. So the baghouse filter really is for the particulates. It's not necessarily going to remove any chemicals or some of the chemicals. I don't see a wet scrubber unit listed on this picture, but that would be another option of kind of getting rid of some of those other byproducts. And then the air goes through the baghouse filter and then out the chimney. And then number 6 there is the air intake for the incineration chamber. So you may be familiar with what an incineration looks like. And this is pictures obviously from Toy Story 3. Woody and his friends accidentally got dumped into an incinerator, and they were about to get burned up, but they got rescued. Not to spoil the movie for you. But they that was their very close encounter with almost becoming ash. So just to check your understanding, which of the following is a negative environmental consequence associated with incineration of municipal solid waste, or MSW? So is it A, the reduction in volume of waste taken to the landfill? B, the production of ash that can be used to produce cement? C, the production of waste heat that can be captured through cogeneration? Or D, the production of potentially toxic compounds as a result of high temperatures? So pause for a minute if you need to. And the correct answer is D, the production of potentially toxic compounds as a result of high temperatures. So you're looking here, the key word in this question is negative environmental consequence. So notice that several of these things are positive. We've got reducing volume of waste, producing ash that can be used to produce cement. They put a positive spin on that one. And then producing waste heat that can be captured through cogeneration. So all of those would be positive things. And the question is asking you to find a negative consequence. So the potentially toxic compounds are going to be your negative consequence. So we've got a lot of waste. It's going to landfills, or it's being burned and producing toxic byproducts and then possibly going to landfills. What other options do we have? So this idea, we talked a long time ago, back in December or November, about integrated pest management. And that was the idea that we wanted to reduce our use of pesticides to a minimum and you only use pesticides as a last resort, and do everything else possible to manage the amount of pests that were attacking our crops. Now, integrated waste management is exactly the same idea, only let's apply it now to garbage. So what we want to do is we want to combine many different methods, that's the integrated part, many different methods of managing and disposing of waste. And our end overall goal is to reduce the environmental impact of municipal solid waste. So if you look there on the diagram, we've got, you can see at the manufacturing level, we want to change our package design. We want to make changes in our manufacturing process. So that's going to help reduce waste at the source. So that's part of integrated waste management, is source reduction. Then you also want to have in your use, change your purchasing habits, do backyard composting, increase reuse. This is also reducing waste at the source, because humans, at our houses, are the source of municipal solid waste. So anything we can do to reduce our waste. And then as you move to the disposal, the waste and disposal end of it, you've got recovering things for recycling and composting, doing industrial composting. So that is a form of waste reduction at that level. And then the very last thing, after you've recycled everything you can recycle, after you've composted everything you can compost, after you've done everything you can earlier to change behaviors and to change manufacturing processes to reduce things at the source, then you finally have a little bit left over. Whatever the waste is that's left over, that needs to be disposed of either through incineration or the landfill. So the idea is we don't just throw everything away. We want to reduce our waste along the way as much as we possibly can. That brings us to our final topic, which is a very special type of waste called e-waste. Now in this picture here, you can see, if you look closely off to the left and then down in that bucket in the front, we've got computer like chips and motherboards and things like that. And what this person is doing is she's got a fire. She's sitting indoors. She's got a fire going underneath her table, and she is melting these motherboards and extracting the valuable wires from them. Notice she's not wearing any gloves. She's not wearing a mask. She has no personal protective equipment. She's doing this with her hands and her possibly some tweezers. And she's going to pull out everything that's valuable and set it aside so she can sell it later. So this kind of waste is electronic waste, also known as e-waste. And it is, the source of this is improperly recycled consumer electronics. Now I know you don't think about it, but just about, so many things in our home now use electronic equipment. So, you've got a toaster oven that doesn't work and you're like, oh, I'm just going to throw it away. Well, if you throw it in the trash, it's possible that it's going to get shipped over somewhere like China, and someone like that lady is going to be extracting the valuable metals from it. We've also got lots of other things, computers and TVs, when you're done with them, especially like the old TVs from the 1950s and 60s and 70s, the cathode ray TVs. Those have about 2 pounds of lead in them. They've got gold in them. They've got lots of valuable metals that are also potentially toxic. So people would get a lot of money for trying to extract those metals from those old TVs. Cell phones, MP3 players. I know we don't really have those anymore, but all your old cell phones have lots and lots of valuable metals in them that it's worth their time to recycle, to try and melt down and recycle. And then any other electronic device that contains precious metals. If you have a camera, even like things, like I said, simple as a toaster, your microwave oven, even like those random, like, little like Game Boy devices or other handheld devices, even power strips have these valuable metals in them. So what ends up happening is when they are quote unquote recycled, a lot of times they're being stuck on ships and carted across one of the two oceans and sent to either China or Africa, and where poor people who have very few other options are dismantling these electronic devices by hand, like in that picture, melting the wires and using fire and creating toxic fumes, and they're doing this in really poor working conditions. And it's not because they choose to, it's because this is their option. They don't have another option. So the solution to this problem, and this is a very big problem, it's like a burden that developed nations are putting on the developing world because we're sending our trash to them, like literally putting our trash on ships and shipping it to them. So our solution really is to recycle responsibly. So if you do have electronic waste that needs to be recycled, I encourage you to go to eStewards.org and look up a certified electronic waste recycler in our area who is going to do things properly. And if you want to get any more information about that, you can Google the story of electronics. It's done by a group that researches the life cycle of different products, and then they create these cool, interesting little videos about them. So I encourage you to take a look at that. And that is all we have for Module 53.